What makes a good hashing algorithm? So a good hashing algorithm will generate unique locations to avoid data collisions. So a really good one would generate unique locations on all keys. It should spread the generated indices uniformly over the size of the data structure to avoid clusters of data. So it's a bad sign if data is clustered. So let's say we've got 100 memory locations, we're using 10, and they're all between memory locations, I don't know, 1 and 25. That's known as a cluster because they're clustering to one area, which is, again, it's a sign that there's going to be collisions going forwards. It must be capable of creating enough unique indices to cover the size of the data structure. So basically, if you've got 100 memory locations, your algorithm would be capable of producing the number 1 to 100, covering the entirety of your data structure would be a good hashing algorithm. Depending on its use, it should either be very fast, which is typically where you find you want for databases, or very, very complex, which is where you'd use for encryption. And you look at hashing and encryption in the networking unit. But again, there's videos on that, private and public keys, things like that. So it's either going to be designed to be very fast or very complex. You don't get a hashing algorithm that is very complex and very fast. All right, so you're kind of going to lean towards the speed or the complexity when creating the indices from the keys. And it must deal with collisions appropriately if they do occur. So collisions can occur in a hashing algorithm, but it's about what you do with it when they do. Okay, so those are the things that make a good hashing algorithm.